The diagram shows a circle, centre O, radius r, centimetres. The points A and B lie on the circle such that the angle AOB is 2 theta radians. Find in terms of r and theta an expression for the length of the chord AB. So that's the chord, this one here. So if this is r, then what we probably need to do is use the cosine rule. And so we can say that AB squared would be equal to r squared plus r squared minus 2 times r times cos 2 theta. So that's going to be 2r squared minus 2r squared cos 2 theta. And therefore AB is going to be the square root of that. We could take an r out of there, 2r squared minus 2r squared cos 2 theta. We could take r out, but I don't think it's worth it. It's 1 mark. Surely we've got that mark. Okay, so we're now given the perimeter of the shaded region is 20 centimetres. We want to show that r is equal to 10 over theta plus sine theta. Okay, so the perimeter is going to be made up of this arc. Now we know that L equals r theta. In this case the angle is 2 theta. So the perimeter is going to be equal to 2r theta, because of the angle being 2 theta, so 2 theta here instead of theta, plus the AB. So in this case I am going to take out that r, and then under the square root we've got 2 minus 2 cos 2 theta. And unfortunately the only way I see of getting from this to the expression that they want is beyond the scope of the course. So I'm going to do a little rethink up here about the length of AB. And what I'm going to do is I'm going to split that into a triangle like such. So this angle is theta, this is r, and then compared to theta this is the opposite and this is the hypotenuse. So if I call that x for a moment, I can say sine theta is equal to x over r. So x equals r sine theta, and therefore AB would be 2 of those. And we can get from there to there. But if you actually did what I did in the first place, which I think is what a lot of people would have done, you can't get there without using information that's actually not in this course. But anyway, we've fixed it, and therefore obviously an alternative answer there is AB is 2r sine theta. So that's an alternative up there. And so we have 20 equals 2r theta plus 2r sine theta. Divide right the way through by 2, and I've got 10 is equal to r theta plus r sine theta. Factorize on the right, and then divide by theta plus sine theta, and we get r is equal to 10 over theta plus sine theta. So we got there. Okay, given that r and theta can vary, find the value of dr d theta when theta is pi by 6. Okay, so we want to find dr d theta, which means we've got to differentiate this. So I'm going to rewrite that as 10 theta plus sine theta to the negative 1. And now I can use the chain rule. So dr d theta is going to be negative 10 theta plus sine theta to the negative 2. But now remember we have to multiply by the differential of the inside here. So differentiating theta gives us 1. Differentiating sine theta gives us cos theta. So that's going to give me negative 10, 1 plus cos theta over theta plus sine theta squared. And we want dr d theta when theta is pi by 6. So dr d theta, given that theta is pi by 6, I don't think that's going to give us anything nice, even if we just use our standard angles. So I think I might go for a calculated answer here. So what have we got? Oh, first of all, let's make sure the calculator is in radians. And I have negative 10, open a bracket, 1 plus cos of pi by 6. And on the bottom we have pi by 6 plus sine of pi by 6 and we need to square all of that. And that gives me negative 17.81. Okay, so we're now given that r is increasing at a rate of 15 centimeters per second. So in other words, dr dt is equal to 15. We want the corresponding rate of change of theta. So d theta dt, using the chain rule, is d theta dr dt. So that's just going to be, so that was negative 17.81, I seem to remember. Yep, okay. So it's going to be, so that was dr d theta, so d theta dr is just the other way up. 1 over 17.81 times 15. And so what have we got? 1 divided by last answer is that, and then multiply that by 15. And that gives us negative 0.84. And that will be in radians per second.